I'll start this video off by showing you what this is all about. It's basically a rotating crystal orb that changes colour, projects into a metal background, which is quite attractive, and it's solar powered, which is nice. So at night time it starts itself and it does this, and I have to say, a fair amount of noise. But that's okay. So now we've seen it in action, it's time to take it to bits. So here's what it looks like in normal light, and it's quite neat. It's got this solar panel at the base, this solar module should I say, with two panels, each with two sections in it, giving the 4 required to charge a nickel-metal hydride cell. And when you put your hand over them to block it, it glows dimly inside and it starts rotating. It looks quite neat. This housing looks quite manual. This looks like it's been sort of tack welded all the way along. This does possibly suggest it's made in India, I'm not really sure. Hold on, I'm just going to look at the label. It's imported via the Netherlands, so that's about it. I don't really know where it's made. Right, tell you what, let's start by taking the bottom apart. I think I can actually slide this off the tube, but there are wires, and it's going taut, so I'm not really sure how well that's going to work. We shall start at the very bottom. So I shall whip the cover off. When I saw this and it said rotating, I wondered, is it going to do that thing they say something like rotating, but it actually turns out it's just lights flashing in a pattern, or even just the colour cycling. So I was quite pleased when I found out it does actually light up. I'm not sure how waterproof it will be. We can analyse that as well. We can see how likely it is that water would get in. So inside, oh, this is so bulky, it's going to be quite tricky. Inside is a battery and a circuit board with the standard little solar chip in it, but other stuff as well. That does actually make sense, because one of the things that the inductor here is actually in series with the LED, and it relies on the LED not conducting at the sort of standard battery voltage. It relies on it only conducting when this is given a boost, and then it dumps its magnetic field and produces that higher voltage to make the LED light. So, right, tell you what, there's also hot melt glue under here, sealing which are not easily going to be able to get these wires out. I think I may have to investigate this. Right, tell you what, I shall investigate it and I'll be back in a moment. It has been reverse engineered and it's got a very odd piece of circuitry. I shall show you that in a moment. If you wish to try and reverse engineer this yourself, then take a snapshot of the screen now. This is the back of the circuit board flipped. This is the front of the circuit board. Values where they're not visible have been written on. Right, so things worthy of note. We've got a standard YX805 chip. This is the standard solar powered LED chip, but you can't just stick a motor in parallel with the LED, and I'll show you why in a moment. We've got a Pnp transistor, we've got an NPN transistor, a couple of resistors, a Schottky diode, a couple of capacitors, and the inductor. It's actually really simple, but the circuitry itself is quite complex. Now all I have to do is pick up the right notepad, because I've got 2 here, make sure I bring the right one in. Let's zoom down, and this time as a special treat I'll actually remember to zoom back out again afterwards before I actually start pointing at things off screen. So we have the 1.2 volt nickel metal hydride cell. What capacity? This one, it's 400 milliamp hour, and it provides a 1.2 volt rail and a 0 volt rail. We've got the solar panel, which is basically 4 sections, half volt each for 2 volt. Where is that? Where have I put that bit? I have misplaced it. It's down below that side. That's all right. I won't bother trying to dig it out. But we have the solar panel, and it uses the YX805 chip. Now, there are a couple of things happen. There's effectively a diode inside that, so the current flows in a one-way direction to charge up this battery. But it also has a dusk sensor that measures the voltage across this, and as soon as it goes below a certain point, it will then start running the circuitry. And what actually happens is this. There's an inductor, 150 microhenries in this instance, but you can use different values. 150 microhenries gives approximately 10 milliamps of current through the LED. Going higher actually results in lower current. But that then goes through a Schottky diode. They've chosen that because of it's got less losses. A silicon diode is about 0.6 volts drop roughly. A Schottky is more like 0.2. And it goes down, and in normal circuitry, normal solar lights, you wouldn't have that diode. You just basically have a straight LED down there. But in this case, it goes through that, and there's a capacitor in parallel with the LED because it's the colour changing one, and because they need to actually store their settings, so to speak, where they are in the colour cycle, they have to have a capacitor across it. If you didn't do that, it would just stay red all the time, because this is pulsioned off, and every time it did it, it would reset back to its initial colour. So the way this works is when this is off, current can't flow down. A little bit of current will flow, but not much, because the forward voltage of this LED is going to be somewhere in the region of 2.4 volts-ish. And that's not enough to light that from the 1.2 volt supply. In some solar lights, you get a dead LED that's actually passing current, and it will actually effectively be draining the battery even when it's off. But the current the voltage is boosted up using this inductor. So what actually happens is it bridges this end of the inductor briefly to ground, and it creates a magnetic field in it, and then it opens the circuit, and that then adds on to the voltage that's here already, and it goes through this diode, and the current flows through the LED, and it makes it light. So by repeatedly pulsing that, a fixed frequency is locked inside here, it can make the LED light on demand. If you were to stick a motor in series with parallel with the LED, the motor would probably just pass current because it doesn't have a sort of forward voltage like LED has. So current would just flow through the inductor, that diode would go through the LED, the motor might just crawl around all the time, it would drain the battery flat. So to control the motor, they've got an NPN transistor, a capacitor across the motor, just for suppression reasons. And to turn this transistor on, you have to take it 0.6 volts or more above the emitter, the connection that goes down to the 0 volt rail. But really oddly, and this took me a while to work out, they've got a Pnp transistor, and the way a Pnp transistor works is that it normally switches to the positive rail, and you actually have to take the base negative by about 0.6 volts to actually turn it on. So what's actually happening here is that because this is finding a low current path through the LED that's off, the sort of colour changes circuitry in that, this ends up close to 0 volts. The emitter ends at near 0 volts, but the base is being pulled up to 1.2 volts. And in the case of a PNP transistor, that will turn it off. However, when this starts operating and you get about 2.4 volts across this, then this will be about 2.4 volts to 3 volts, depending on the state of the LED, what colour it's in, and then the base will be at 1.2 volts, which is less than that, which means that transistor will turn on, and the current then passes from there through this resistor and turns on that transistor that turns the motor on. So basically that means that only when the LED is lit, the motor will run. It's very strange, but there's something really nice in this thing. Let's zoom out before I forget to zoom out. Let us actually bring this in and put it to a nice height, and we'll focus at that height. That should be good. Either that or I've just knocked the whole rest of the video out of focus, as occasionally happens. The rotating orb is a bit of a treat. I'm going to brighten this up because it's not that bright. 'Tis now. The rotating orb has something that I was not expecting. Let me shove it in the end of this pen. It's got a ball bearing race. That is really unexpected. The orb itself, if you very carefully avoid putting your fingers into these recesses, you can bayonet cap it apart. If you put your fingers in there, it actually hurts. It nips them as it comes out. But the bearing race is actually just pressed in. There's a tiny crack there, just as you'd expect from friction fit into plastic. But it's very chunky. It's very nice. I thought it was just something that had been repurposed from something else, but it's not. So the bearing race clips over this little latch here, a pillar with sort of springy latches, and that's what holds it in place. And the LED is in the middle of that. It doesn't rotate at all, just the orb rotates around that. So the LED is literally just based down a little channel in there with its wires and just sits in the end. On the side of it is a drive. I'm going to try and show you this. I'll zoom down. Are you going to see it? Yes, you can. It's got a drive here coupled onto the motor in here. Let's take this apart. What that means is that once the bearing has been clamped onto there, this tooth section in here, this inner bearing, runs on that so that it can drive it round, but everything in the middle here is absolutely static. Let me unscrew these. Am I going to regret this? Probably. Am I really going to regret it? Not really. I want to know what's in here. Gears, ultimately. Not that many gears, I wouldn't think. Because the motor is only being run at about 1.2 volts. If that. Just a couple of gears. Actually, it's a few gears. The motor in the bottom here. Where is the motor? I'll tell you what, let's take him out. And that out. There's the motor down there. Going onto that white gear, then onto that gear, then onto this one. Have I got them in the right order? I think so. Then onto this one. These are just all identical wheels. It doesn't use that bit there. And then that's protruding out the side and going onto this outer wheel here, the cog wheel, but the female cog wheel, there must be a name for that, the inner, almost like a round rack, in a rack and pinion sense. But that's quite neat. And there's a little channel bringing the wires up and just ducking it over at the side so it can go through the top. That is quite smart. So that's it. It's a nice light. It's better than I was expecting. All the noise will be from there because ultimately I wouldn't expect this to be making much noise if it's a bearing. And maybe there'll be some noise where it's just rubbing onto the outer teeth. But there we go. It's very neat. It does allude to the possibility of changing the colour of the LED, but the circuitry is so optimised around that LED and its characteristics, and the fact that unlike a standard gallium nitride, say a white or a blue or a gallium arsenide red LED, that this one it's got active circuitry, so it will actually drag that capacitor voltage down once this thing stops boosting voltage. So it's strange. I don't know if it would work with a standard LED or not, because this is very, very delicately balanced. I think that was just created purely by experimentation in the lab and actually seeing what worked. But it is pretty good. I like this globe in particular, and the drive mechanism for it. Just this bit alone is actually worth that, because it is quite nice. But there we go. Actually, a really good light. Oh, I should mention, just in case you live in the Isle of Man, I got that from Jack's Home Stores, GAC Home Stores. In particular, this one came from the Ramsey branch.